Algebra 2A, welcome back. We are taking a look at Lesson 25, Day 1. Find the measures of central tendency and dispersion. Lesson 25 is one of our statistics lessons. Statistics is the practice or science of collecting and analyzing numerical data in large quantities. So we can find trends and patterns when we look at data that's collected in a large quantity. Some measurements that we can take are called the measures of central tendency. First is the mean or average of n numbers is the sum of the numbers divided by n. The mean is denoted by x bar, which we'll see in our calculator here in a second. For the data set x1, 2, 3, and so on, the mean is adding up all the numbers and dividing by the numbers that you have. So we'd add up our set of numbers, x1 plus x2 plus all the way to x sub n, whatever total numbers are in your list, and then divide by the total. The median of n numbers is the middle number when the numbers are written in order. If n is even, the median is the mean of the two middle values. The mode of n numbers is the number that appears most frequently in the list. There may be one mode, no mode, or more than one mode. So if there's multiple numbers that occur the same amount of time, we list all of those that tie. If each number only occurs once, there is no mode. Example 1, calculate the mean, the median, and the mode. To do this, I will use a graphing calculator. So go ahead and get your calculator out and ready. The first thing you'll do is you'll locate the stat button. So stat is right here in the middle. You can hit your stat, and then we're going to go to edit. So this is where we can put in groups of numbers and start to make calculations. So we'll have our stat list. So if you missed that, I did stat and then edit. Now I'm going to put in my list, 16, 13, all the way down. Each time I enter a value of data, I just hit enter, and it's going to bring me to the next position on the list. Now I'm just going to double check. I've got a 16, 13, 12, 15, 18, 14, 14. So our calculator can calculate the mean, x bar, and the median. The mode we have to find ourselves, so we'll do that here in just a second as well. You probably already know it. Next thing we can do once we've got our list entered, we'll second quit back to the main menu. We'll hit stat. Now we're going to calculate, and it's the very first one. So one variable stats. That's the one that we're going to look for. Hit enter. Your list one is the one that we want in there. There is no frequency list, so we're just going to hit calculate. So we'll go down to calculate, hit enter, and now we can start reading some of our data. So first, our mean, 14.57. We'll round that to the nearest 14.6. The median you have to go down, is 14. There would be our median. And lastly, our mode, number occurs the most. We have to look back at our list, is also 14. It occurs twice. So there is your values of measure of central tendency. If you need to, you can go rewind the video. You can practice putting in your data. But you should get an online graphing calculator or your own personal calculator and practice putting in a list and finding the data. Next, we'll look at measures of dispersion. The range of a data set. So we're looking at measures of dispersion. We're looking at how spread out our data is. The range is the difference between the largest and smallest value. Now the variance of the data set is the average of the squared differences from the mean. So we are going to look at taking the difference each number is from the mean and then taking the squared differences to find the variance. And then the standard deviation measures on average how far away from the mean the data values are. The standard deviation, sigma, is the square root of the variance and is calculated using the following formula. Taking the mean difference from your first data point squared plus the mean difference of your second data point squared plus the mean difference of your last data point squared, and then divide by n. To calculate the standard deviation, we are going to use our calculator as well. So we will do what we just did in example 1 and put our data into our calculator. So the next thing you can do is get out your calculator. You're going to go into Stat, Edit, and to clear a list, you're going to go up to L1, hit Clear. So what I'm going to do, I'm going to pause the video here in a second. I'm going to put all of my data for A into L1 and then all my data for B into L2, and then we're going to find the range and the standard deviation for each of those data sets. So here in my calculator, I have both data sets in. If you haven't done that yet, you can pause the video right here and put in your list for A and your list for B into L2. Now we're ready to calculate our range and our standard deviation. So I'll first hit second quit, and then I'll go to stat, and then I'm going to hit over 1, calculate 1 variable stats. And the first list I'll do is list A. I'm going to put in the L1, go to calculate. Now your standard deviation is going to be this value right here, the sigma x is our standard deviation. So each number is about on average 2.15 away from the mean. So I'm going to actually put in my standard deviation first, 2.15. Okay, now your mean, or your range, excuse me, is the difference between your max and your min. So you can head down to here. Here's your min, which is 3. Your max is 9. The difference between those is going to be 6. So there would be my range. Now we're going to go and calculate B. So we'll start by hitting stat and then go to calculate and then 1 variable stat. So everything we've been doing is the same so far. But now list B is in my L2. I'm going to hit second 2, which will change that to L2. And then I'm going to go to calculate. And there's my stats for this problem. So my standard deviation first is my sigma 1.85. And then my max and my min. I have a 17 minus 12, which is 5. 17 minus 12 is going to give me 5. Lastly, we'll look at a number called an outlier. An outlier is a number in a data set that is much larger or much smaller than the rest of your set. So we can start to look at the effect that the outlier has on your data set. When we have an outlier, it can change your mean and make it look either much higher or much lower depending on what the outlier is than the rest of your data. So sometimes when statistics for large groups of numbers are presented, the median is used as the middle value because the mean can be influenced by the outlier. So sometimes you'll see like average household income. That is a median value because sometimes there are some outliers, some people who are their income is much higher than the average person, so those numbers are not influencing the average. In problem 3, we're going to identify the outlier in the set and then find the mean, the median, the mode, the range, and the standard deviation of the data set when the outlier is included and when it's not. So we are going to start by taking a list of the numbers with the outlier, and then we're going to take the 35 out, which is our outlier, take that out, and then make another list with the numbers without the outlier. So we're going to head back to our calculator and we're going to put the list L1 with the outlier, and then we're going to make another list in L2 without the outlier. So that's what we're going to do next. So we're going to grab our calculator, we're going to head back to Stat, Edit, and you can clear both lists, clear L2, clear L1. Now we're ready to start. So in my first list, L1, I'm going to put it with the outlier, then I'm going to put it without. So next time you see me, I'll have both my lists put in. What you're looking at on my calculator is L1 with the outlier of 35 and then L2 without the outlier. So now we're going to go and calculate with the outlier and then go back and calculate again without. So to do that, I'm going to hit stat. I'm going to hit calc, 1 variable stats. With the outlier was my L1, so I'm going to hit second 1 to change that back to L1 and then hit calculate. Now we can start to record our mean, median, mode we'll have to do on our own, standard deviation, and range. So when we calculate with our mean, with our outlier, we're gonna notice that our mean is 9.2, median is 6, mode is 6, range is 32, very large, shows a big dispersion, and then standard deviation is 9.3. So each number is on average about 9 away from the mean. Next thing we'll do is go back to stat, hit calc, one variable stats, and this time we'll change it to list 2. So we calculate without the outlier. And there's our results. Now we get a mean that is 6, a standard deviation that is 2, a median that is 6, a mode that is still 6, and a range from 3 to 9 that is also 6. So we can see our numbers are changing quite a bit. And the numbers I want you to look that change the most are the measures of dispersion and the mean. So those are the ones that are affected by that outlier of 35. So right here, we can see we had a mean that dropped down by 3. We had a range that changed by 26. And then we had a standard deviation that changed by 7. So those measures of dispersion, which the mean, the dispersion does matter as well, are the numbers that are going to be greatly changed. So when you have an outlier, it's best to use the median to represent your data set, because that's going to be a more accurate representation of what all your numbers are doing. So there's our results for day 1, and you are ready now for the day 1 assignment. You can go ahead and good luck, and we'll see you next time.